D2DNY, Real World HVAC Simplified. And today I'm going to be troubleshooting some rooftop units. I'll show you how to do it. If you come on a service call, you got a whole bunch of rooftop units like this particular roof right here. This is a large warehouse. You can see we got over 20 pieces of equipment. So the customer calls and they said, hey, you know, our floor is warm. And you said, okay, customer, what unit is down? Which one is working? Which one is not working? What's your issue? We don't know, but our floor is just warmer than normal. Okay, that helps a lot. So you come up on the roof. I'm gonna show you how to tackle that problem without getting exhausted, because it's hot as balls out here. It's 80+ degrees and you're up here, you don't want to waste your energy opening this panel, that panel, checking this compressor, that compressor, only to find out that the compressor is working. And by the time you get to the one that's actually down, you're already exhausted. And you're like, oh, you know. So I'm gonna show you how to do that like a pro, how to figure it out like a pro. And we're gonna dive into troubleshooting one or two of the actual unit that's actually down. Okay, so stay tuned for that. If you haven't subscribed, give this video a thumbs up. All right, let's get into it. So you see this right here? That's water. If you walk up to a rooftop or any AC unit, doesn't matter, on a hot day, and you're getting this much condensation emitting from the drain or ejecting from the drain, and you can physically hear your compressors going, there's no ice buildup. Listen, it may not be perfect, but you can skip that one for now. All right, that's not the reason why you're on this call. All right, let's move on. Okay, here's another one. This is a smaller unit, right? Same thing. We got water coming out of here. All right, it ain't as much as the other unit because it's a smaller unit. But once again, you don't have to. It may not be perfect. It may not be 100%. But again, most likely, this unit is not the reason why you're on this call or why you're on this roof, why you're on this hot ass roof. Okay, let's move on. Okay. Here's another one. It's another York. All right, Johnson Control. Same. All right, let's go around here. Oh, here it is. Look. There's lots of water here. Lots and lots of water. If you look around here, oh, look, there's crap in the drain too. Look, there's water. Water all the way here. All right, there's lots of water. Let's see, look all of the pad. That's a lot of water from this unit. All right, don't waste your time on this one. Again, it may not be perfect. It may not be working at 100% efficient or whatever, but I doubt that's going to be the reason why you're here. Keep on moving, keep on looking. Let's go. Okay, so here's another unit. This is a carrier. Let's take a look around. First of all, we got our condensing fan spinning. Right, they are on. Let's give that drain an old check. Wait a minute, someone is already working in it. This must be broken. I'm kidding, that's me. But look, this thing is bone dry. Bone dry. That's just the water from my gloves. It's bone dry. No water on the ground. It's dry. And you might want to stop here and start digging, right? There's some gold here. All right, there's some gold. All right, so I've already got started. We got the condensing fan running. This is an older unit. Let me go to the tag and show you that. So here's the name tag. I can't see the manufacturer date on it, but I'm sure it's old. 20+ years it's going to be. And usually what happens with these older units, they're not as efficient as, you know, newer units. With that said, when the compressors are off for whatever reason, on safety, they're bad, whatever it is, the compressor's contactors could be disengaged. However, so long as the thermostat is calling for cooling, the fan will still run. Really stupid, right? But that's older. We get smarter as we get older. So back in the days, this was okay, right? Simultaneously you're pulling air over the coils for no reason, and you're getting the coil dirty. You're wasting energy running the fan while the compressor isn't on. But again, older standards, 25 years ago, 20 years ago, or 22, you know what it is. All right. So in here, my gauges are connected, and if you don't know how to connect your gauges to your system, go watch my other videos. I got videos on that. I think the very first video I upload to YouTube I was showing how to put the gauges on the high side and the low side. So here you go. I've already checked that compressor on the other side, so I know that there's pressures in it standing. Okay. My evaporator fan. And you know, this is an example in my book of a unit that's in poor maintenance or poor service. Okay. These filters were clogged. Okay. These are what I'm finding so far. So we know that. So what do we know? We know that our thermostat is calling for cooling, and our evaporator fan is running. So those are a plus. We know that our system is not flat. We got refrigerant because based on these pressures right here. Okay. See that's standing pressures, and I verified the same on the other compressor. We know that our condensing fans are running, and so again that confirms that our thermostat is calling for cooling. So this is not a thermostat issue. Here's the other compressor, and again, by my standard, this unit is in poor service or poor maintenance. If I'm doing a condition report on this, I'm gonna tell the customer, hey customer, you know, time to consider throwing this thing off the roof. Okay, so here we go in the electrical section. Compressor contactor, I think this is number 1, and compressor contactor number 2. Not sure, it's not relevant right now, which is 1 and which is 2. All right, but here is your evaporator or your blower motor, and this one here is for the condensing fans. Let me go ahead and pull the coil. Okay, so boom, turns off, right? Yeah, fan stopped. You can hear it. I'll go ahead and put that back. Okay, so we verify. All right, verified. Oh, this is kind of weird. Is this factory? Let's just check the schematic real quick. I mean, again, it's an older year, but anyways, here we got the lockout relays, and these relays, they monitor one per circuit or 1 per compressor. They monitor, this is the amperage. So if the amperage goes to high, it locks out, right? It locks out and current draw, all right? And so 1 for each circuit, and they're tied in with the low and high pressure. So it's a lockout logic, okay? It's just a fancy lockout relay. Well, it's a little bit more than fancy because it does amperages as well, okay? Now my guess is that this system is locked out, and I'm gonna use my tester to verify it. So perhaps you didn't know, this particular unit, the terminal X, that marks X, marked X marked the spot. But this terminal is a diagnostic lockout terminal. And all it means is that if either circuit 1 or compressor 1 or compressor 2 or circuit 2 locks out for whatever reason, whatever it be, and IHAMS or amperage draw or you know, pressures, that's the only 3 things it's gonna lock out on. High amperage, overhamping, which is the same thing, high pressure or low pressure, or if this thing is malfunctioning or malfunction. So those are the 3 things. If any one of those conditions occur, you will get 24 volts on this terminal marked X/info or IFO. All right. And here is the logic on the schematic. 1, 2. I am not going to go into that. I mean, if you guys want me to, just leave it in the comment and I'll go over that. All right. Yes, in fact, the condensing fan motors are right here. One, that's the indoor motor. That's the evaporator fan motor. It has its own contactor, right? And condenser 1, 2, 3. OFM, outdoor fan motor. You can see that they splice in 1 wire, 3, and it's yellow, like we see here on the wire nut. All right, and there's just 1 single pole or 1 pole contactor right here that feeds off all 3 of them. You can see that. So it is in fact correct. Hey, all right, so let's get into it. Let me get my meter. We're gonna just verify and test if we are locked out or not. So now I've got my meter right here, and it's on DC. It's on AC voltage. All right, set to AC volts. See the sine wave on the bottom right here. Ignore that. That's amperage up top. All right. And I'm going and check my info or my terminal X just to ground or C, same thing, common or ground. So you see that one lead and ground, one lead and X, and I'm not reading. Oh wait, what? Oh, I am reading 25, which means we're locked out. Whatever I talking about, I wasn't connecting properly to ground. Let me just go to C, so I can make it happen with one hand. Can I do it? Let's see. Okay, so I'm on C. All right, and I am on X. I'm firmly connected, and I got 25 volts, which means that my lockout logic or logics is locked out. Whether it be high pressure, low pressure, I don't know, or overamps, I don't know. We're gonna have to do a reset to find out. All right, let's do it. Now, typically with these lockout relays, based on the way they're wired up or configured, if you simply just push the contactor in, like manually push it in, like you see I'm doing right here now, if everything is okay, it will stay on. This one did. This one did. So maybe this one is not locked out. Maybe it's not calling for that stage, for that circuit. But this one, you know, I already pushed that in and it just stayed on. It's reset and it's running. Let me do an amperage draw on that. The gauges is on the other circuit, by the ways. So let's see what we got here. All right. So we're doing 12 amps. So our compressor is out and running. And all I did, there's two ways to do this. You can turn the thermostat off. Oh, there we go. We just turned off. So we're locking out on something. I don't know if it's high or low or amperage because, well, maybe we're doing 12 amps. I could go check the name tag and see. Hold on. No, actually, I showed you guys the wrong tag. The tag I showed you on the other side wasn't the actual real nomenclature. Here it is. And each compressor running load amp is 10. So we were doing 12. So in this case, I'm going to say we went off an amperage. Whether we are overcharged, whether the compressor is going bad, I don't know. That's more troubleshooting. Got to figure it out. But running load amp is 10. We were doing 12. Okay. And when this thing manufactured, hold on a second. Anyway, so we know that one compressor is cutting off an amperage. We're gonna have to do some resistance testing. Put the gauges on it to see if we are running over pressures or if we're overcharged, stuff like that. Right now the gauges is on the other side. I only brought one pair up, you know. It's not a big deal. And the other side is not resetting, so we're gonna have to dig into that. Let me go and see what I could come up with, and I'm gonna get back. Okay, so another point I want to double check on that circuit, this circuit right here that's been tripping out. And obviously it looks like we're tripping out at amperage because we're doing 12. And again, this lockout board does do amperage as well. So you want to make sure your contactors are unpitted and all your points are making good connections. So I removed the cover. Cover is off. It looks good. So I'm gonna go ahead and do the reset once more. This time I'm gonna try and measure the amperage at all three wires, all three legs. Okay, before it cut out. I'm gonna go ahead and do the reset again. Once you push the contactor in manually, that's one way of doing the reset. You could cycle the power to the unit. That would take a little bit longer. You can go to the thermostat, turn the cooling off, turn the cooling on. You can also pull the common of the logic. You know, there's easier ways. Just push the contactor or cycle the power. So I pushed it in, stayed on. See my amperage up top. It's 8 point. It's in range right now, but I think more than likely it's going to be probably overcharged on our head pressures, because if it was a compressor problem where the windings are no good or resistant is too low, it would be automatically running on high, but it's climbing slowly, as you can see. The fact that it's climbing slowly, that means it's more than likely pressure related. Pressure is related. Okay, so we are at about 9 and change. We're about to hit the maximum. We're at 10 right now. Let's go back on the black wire, because all three lines is pulling good. So we're gonna get to 12, and this is gonna cut off. So I think this is a problem maybe near the condenser. The condenser coil looks shady. I don't know, exactly what's going to be. Or maybe it's overcharged. I got to put my gauges on it and see. But yeah, here you go. So this one is cutting off an amperage. Here you go. Locks out. All right, let me get to the other one and see what's going on over here. Stay tuned for that. Okay, so I'm back again. So after looking, here's what I found for the second contactor or compressor, which is this one right here. So it turns out this wire, this pink wire right here, was disconnected from the back of the terminal block. All right, so basically it wasn't even calling for that circuit. So which means that if I reset this one, let me do it again. So it's reset. If I go to X and C, it should be no 24 volts. Should be not locked out. And that's 15. It's not 24, so it's not locked out anymore. Let me go ahead now and reconnect this and see what happens. Okay, so the wire is back on the terminal, right? We're good now. Compressor is in, it's on. We're doing 7 amps. All right, let's walk around because I have the gauges hooked up on this particular circuit. Here we go. It's not looking too shady, given that this panel is open right here. Seems like it's doing something. It is hot out here on this roof. So the pressure is climbing, and it's climbing. Danger zone. Danger zone. This is R22. Danger zone. It is climbing. It's gonna pop soon. Oh yeah. It is gonna pop soon. We're climbing, and I don't know why we're climbing. I think we're probably overcharged. The coil is in. You can see it. But it's gonna cut off soon. So pretty much, I think we have our diagnostics, right? Look at that. Cuts off 500, or almost 500. I think we have our diagnostic today, folks. I believe, based on what we've seen thus far, when we put our amp meter on this compressor right here, while it was locked out, and we pushed the contactor to reset it, we know how slow the amperage climb and climb and climb and climb until we cut out. So probably, maybe it cuts off an amperage, maybe it was just the pressure's got to 500 and cut off, like this circuit over here. Perhaps if we reset this one and watch it, we'll see the amperage do the same thing. All right, we'll see the amperage climb up slowly, and then at around 12 or 13, which probably equates to about 450 psi, it cuts off. So we can pretty much say that we got to investigate our condenser. Maybe these fans, they're not installed in the correct manner. They're not spinning the right rotation. I think this one feels like it's going the wrong way. Like it's sucking. I gotta check that one. This one here feels like it's blowing out. This one here is blowing out. I think this one here. Let's test that. So it's either refrigerant. The coil is in bad shape. You can see that. You don't need a mirror for that. It's all beaten up. Again, by my standards, this machine is in poor service. Okay. Let's go ahead and look a little further. I won't leave you hanging dry here. I'm gonna just go ahead and look a little further. We're gonna investigate the pressures and these condensing fan motors. Stay tuned. Okay, so far we know that both circuits are locking out. The first circuit was locking out automatically. We saw the amperage go up past the normal running load amp. We anticipated that it could have just been a faulty compressor, the resistance reading, the resistance value. We never included in there the pressure reading because the gauges wasn't on that particular circuit. The gauges was on the other circuit. But once we went further and realized that the second circuit, the wire was disconnected back of the terminal block, we put that online, fired up, tested. We realized that the pressures was just climbing slowly but surely. We got to 475 where it cuts out at high pressure. But simultaneously, you could understand that the previous compressor, where the amperage was climbing, we weren't seeing the pressures. Pressures is going up so is the amperage. So I think that we could say that static compressors. I think it's a safe bet to say that it's static compressors. It's just that the pressures is going up. So next thing you want to do now, you want to investigate the coil, which is in bad shape. So we know that already. And our fan motor. So now we're going to go ahead. We have 3 of them and they are running. So I got this paper right here, right? So I'm going to hold it in place, right? You can see that we're getting a nice discharge. We're moving some air. I'm going to come down the line. Number 2, same thing. You know, I'm getting a nice little discharge. It's wobbling up, right? It's blowing up. And we're going under the first fan now. We realize, we see what happened, right? This is sucking in. It's sucking in, right? Why is it sucking in? I think it's going in the wrong rotation, right? Go investigate it, right? Hence your problem. Hence your high pressure, hence your high amperage. This thing is pulling air the wrong direction. It's counterproductive. So it's canceling out perhaps this fan right here in the middle, right? It's fighting against it, all right? So now you're definitely going to be pulling high amps and going at high pressure. So here's your problem. Here's a diagnostic. So should I go further? I'll see. So the fan just turned off, and you could see that this particular fan, the way it's turning this way, which obviously is going to move air in the opposite direction. Even on the arrow, it shows you that it's supposed to be going this way, not this way, right? There's an arrow on the thing right here. It shows you that it's no brainer, it goes that way, right? And it's the reason why. Let's bump it again, because I have the wire pulled here. Let's just bump it again, right? I'm going all the way with you guys today. So I bump it. Okay. So this one is going this direction, which is the wrong direction, right? And look at the other 2. They're going in the opposite direction, right? So the fact that the wind is moving this, but those 2, they're moving in the opposite direction. So let's just check and see why that is. So I'm not even going to delay. Obviously these motors were replaced. As you can see from the condensed capacitor hanging back here, that's not the factory setup. The factory setup had all the capacitors in this bracket right here. All 3 of them was right here. So it was this motor was replaced. You could tell. So whomever installed this motor, I know for a fact, without even checking on the tag. Perhaps I could see the tag. I don't know. It's kind of difficult, but without even checking the tag, I know for a fact that this thing right here has to do with the orientation. I'm going to unplug it. If you can see how it is right now, it is black, white to black and black to white. It's crisscross. I'm going to unplug it, and then I'm going to put it direct, you know, the other way around, and it should take care of the rotation. Let's do it. Okay, to all you smart folks out there, if you were thinking it, you were absolutely correct. Yeah, I gave it to you, you're correct. You see, take note, my meter is in capacitance. It's in capacitor, the settings. And I'm currently reading 1 microfarad. This capacitor is bad, the run cap is bad. And it's the reason why that fan, condensing fan, was turning in the wrong direction. It wasn't because the wires or the rotation configuration in this particular motor, because this motor has a rotation configuration. Not all motor has that. This particular one does. That wasn't the issue though. The configuration was fine. When I flipped it around, I realized I was getting the same wrong rotation. So I quickly realized it was a capacitor. So if you was one of those smart asses, wise guys, that said, hey, no, it could be the capacitor. You were right. And just for that, I'm gonna give you a bonus. So I have this unit capacitor disconnected. You can see it's all safed off right now. And the bonus here is you can run this motor without the capacitor and get it going in the right direction. I'm gonna show you how. All right, first you wanna do this. You wanna get the blade or prop spinning or turning in the direction which you think or you know it's supposed to go, like so. And then you want to go ahead and power the contactor. So see right now, it is in fact turning in the right direction, the direction which I spun it. If you need to know more about that, leave the questions in the comment section. All right, so now you can see clearly we're going around where the arrow is pointing, that direction. So I'm gonna, as a temporary fix, I'm gonna let this puppy run, let this machine run, let this bad boy run that way for now until I get a capacitor. Stay tuned. Okay, so there you have it. There you have it. That's the diagnostic. We're gonna have to clean this clean and comb this raggedy coil. Even though I got the fan going in the right rotation, it's not moving as much air as it should because it's missing the run cap, you know, so it's still working, but as you can see here, there's literally no suction in this damn condenser, right? So we're gonna, and look at the fins are all bent. So we're gonna clean, comb the fins, and if we're still having high pressure problems, which like we do right now, still climbing, we're gonna have to recover the refrigerant and weigh it back into factory specs. But right now the problem is head pressure. That's the diagnostic. The diagnostics is head pressure problems due to dirty clogged condensers, damaged condensers, and a bad capacitor for this condenser fan motor right here. That's your diagnostics. All right, like this video, give it a thumbs up, subscribe if you hadn't. Real world, real time, real HVAC, simplified.